O, fajnie. Cześć wszystkim. Prezentacja będzie po angielsku, ale jeśli chcecie ktoś porozmawiać po prezentacji, to możemy po polsku. To nie problema. So, I bet every one of you saw this title and think, DI? Maybe this guy meant AI? Why? What do I don't know about DI? Because DI is our regular exercises, right? And we work with it on a daily basis, nothing special. However, there is some interesting things I'd like to present you. My name is Dmytro. I work as a software engineer more than 7 years. Primary, it's fintech domain. And you know what? The thing is, I guess that we all used to work with enterprise applications, right? We used to learn a lot about the Spring and so on. So let me actually start with ice-breaking question. Who is using Spring on the daily basis? Okay, great. Who is using Quarkus? Come on, no one? Okay. Micronaut? Cool, because if you were, I wouldn't present it. So, true, why we love Spring and why the Spring works fine for us. The thing is, Spring gives us a lot of opportunities, and the DI implementation for the Spring is quite straightforward, right? We can separate infrastructure code at one part and use business logic on the second part. It is very convenient, right? Because we can just application faster. We can have representation of code relies on the business requirements, and it gives a lot of cool benefits. But the thing is, Spring has a lot of disadvantages because we use a lot of proxies, we have a lot of class loaders. It's really hard to debug something or analyze errors. I guess some of you who did thread dump, you just saw this saga of stack traces just to understand that here was null pointer exception or illegal state exception. It's nightmare in a lot of cases. But yeah, anyway, Spring is a good solution. And the thing is, if Hemingway was asked, what do you think about Micronaut? He would answer, it's like Spring-alike, but native. What means native? Roughly speaking, native means that if you have something that you can move from runtime to the compilation, you move from runtime to the compilation. And it turns out that it gives plenty of benefits. What the benefits are? So first of all, we don't need to use reflection. We can avoid it. We can avoid using a lot of class loaders. We can avoid using proxies. We can optimize the memory, so it's less footprint, memory print. And basically, error handling is much better. The thing is, this list of advantages of Micronaut is not full, because there is another thing. It's annotation processing. Micronaut is awesome at the annotation processing, and I will show you a bit later about it. Yeah, anyway, let me actually show you one demo, how it works on a high level, and we can try to kind of develop a lean startup payment provider. Okay, maybe some of you works with payment providers, and what payment providers do is actually do payments, right? So nothing special. So we have decision service. This decision service should decide whether we can do payment or no, and at the same time we have payment service. Payment service is actually do payment based on the decision. Very straightforward, nothing complicated here. And everything starts with constructor injections, right? Quite typical approach when we can inject our dependencies through the constructor. But how it works in Micronaut? The thing is, Micronaut doesn't provide any of custom annotations. It extends and implements the GSR 330. And we don't need to use here kind of stereotypes or so that we have for Spring, like repositories, components, service. We don't have here. Instead, we have this funny annotation, which is called singleton. So right now, decision service is added to the context. And let's add the payment service as well to the context, right? And we can do the decision service, decide. Okay, let's go to the service and let's try to run it. And we expect that when we run the payment service, we expect to have their positive decision for the payment. So payment service, pay. Okay, let's run the test and take a look what we have. Drum beats. Yay, fine. Test is passed, no problem. Everything is straightforward. And the thing is, Micronaut has very interesting aspect of injecting dependencies. The thing is, you can inject anything you want, but in addition, it provides entire list, enormous list of wrappers on your dependencies. It wrappers, I guess, very similar when you have Spring service and you have a list with the interface, type it with the interface, and it can inject a set of implementations, the dependencies that implement this interface. Something similar we have in the Micronaut as well. So if we go here and add the optional at the part of decision service, and we can change it to the optional, okay, refactor, and we can say like decide or else false. So if we don't have this dependency, we can just return false. So it means that, oh, make some or else like evaluate or so with the supplier. So we just need to remove decision service from the context. Let's run it, and we expect this test can fail. The thing is, here we have not really full list of potential wrappers, but it's quite common one with already out of the Java package, like map, collection, stream, optional, array, and there are a lot of their custom, like bin provider. We can take a look a bit later about it, what it means, why it's used. But here, let me back again, remove it from a singleton, let's adjust the context. Happens one interesting aspect. Okay, it's quite easy when we have one dependency, right? Only one dependency. But I want you to be fair with me, okay? I'm gonna ask you 3 questions. And if you lie, you fail, okay? Who's from Poland? Oh, come on, right hands, who's from Poland? Okay, great. Who is subscribed to Netflix? Come on, cool. And the final question, it's very important, guys. I have to just request that you have to be fair with me. Who has only one implementation for one interface? Come on, be fair. It's quite a common one. Yeah, so the thing is, it exists, and there are multiple implementations for only one interface. And what we do with Spring when it comes to the multiple implementations? Qualifier, right? We do qualifier by the name, or I don't know, by some regex. Qualifier is actually quite rich for the finding potential candidates. But there are 2 problems with the qualifier. The first problem is that qualifier is not contract aware. What it means, you can qualify almost anything, and you can put there any string. And what happens? Something is not correct, right? Some qualifier is not doesn't exist such dependency, and you like wait in a couple of minutes when context is up, when it starts, and then it fails, and like, oh gosh, I need to, I don't know, change name, and then back again, you're waiting for it, and it fails back again. So it's like a lot of problems with that happens, especially when you're developing a library. You have, for example, a library on the top, and this library, I don't know, like utilized by multiple microservices or other libraries. But Micronaut gives a lot of cool benefits when you have potential candidates and how to avoid ambiguous exceptions here. So first of all, we have here payment repository, and it implements 2 classes. It's MySQL payment repository, so we just want to save something, mock, and we have PostgreSQL payment repository. So the same. And let's do this one. we back to the payment service, and we try to implement here, inject our payment repository. Okay, let's add it to the constructor. Okay, great. Just because it could be a bit more convenient for everyone for the presentation. And we want to save something as well. Save. And just want to make sure that we added it to the context. So singleton, okay, great. And PostgreSQL, singleton, okay. Let's go to the test, and we will try to do save operation, assertions, assert true, and save. Do you know what's going to happen? It fails. Yeah, you're too slow. It fails because we have ambiguous candidate, because we have two candidates that could be outwired. So if we talk on the Spring language, we can use qualifier, JSR qualifier. It's called named, and here named, and put here MySQL. And let's run it, and we expect that everything should be fine. Test passed, no problem. Why it happens, the thing is, named is not case sensitive, so it just appends the parameter of your name and the interface name. It concatenates and tries to find this candidate. But as I mentioned, right, we don't kind of resolve here these two problems that was mentioned before. Still, I know that strings are mutable, it's okay, but people, developers, change it constantly. You every time change strings. So just to make kind of approach of construct aware in your library for the potential candidates, you can do this thing. And as I mentioned, Micronaut is awesome at annotation processing. It tries to evaluate annotations and do binding at the compilation time. You don't need to kind of read all the entire hierarchy during the runtime, understanding what is what, how it should be binded, and all this stuff. Instead, we can do our annotation. We can call it as MySQL. Okay, let's be here. Then we here retention runtime. I checked actually, it works fine with any retention policy, and that qualifier. Okay, great. Go to the payment repository, and let's replace to the MySQL. Let's run it. And it's success. Like, we did really good binding by the annotation by the MySQL, by the same naming, but this time we can create a set of such annotations. And this set of annotations we can use for our needs, and we just can definitely know what we inject, how we inject it, and what the potential candidates exist. And for the same, we can use as well PostgreSQL. And the test should fail because Postgre returns false. But yeah, the thing is, hi from PostgreSQL. It's fine. But as I mentioned, the thing is, it's not really abstract level, right? Because we use interface, it's okay, we have to use interfaces, high-level abstractions, but still we inject concrete dependency, we inject concrete implementation. It's not really always convenient. Let's, for example, team lead comes to you and says, like, we're gonna to move from Azure to Amazon, and we need to change the different repository, and you have to change annotation, you have to change properties, and so on and so forth. It's kind of quite invasive operation, right? Because you need to like rework entire project or some kind of bunch of services. So in this case, possibly it would be really convenient to have kind of conditional injections. And why I mean about the conditional injections in Spring, for example, we would use bean post processors or some other things that are not really convenient and reflection oriented. But here in Micronaut we can use kind of value oriented or configurable injection. So how it works? Here we have configurable annotation, and we have here a lot of okay, here we have environment as one property, and we can produce here a lot of properties. And for example, we want to use MySQL for our local purposes, but Postgre for the production, okay? Let's assume that this information could come from the property file or YAML or XML if somebody is using it still. So configurable payment repository, and let's go to the MySQL and say like, okay, you're a configurable payment repository, okay, and Postgre as well, but this is for prod. Great. So what we need to do here, we go to the payment service and let's run it, and we expect that MySQL should be used. Okay, we use here MySQL, awesome. And somewhere, I don't know, some environment, you can have like prod or so. Let's run it, and 8 fails. So we have here potential candidates from the PostgreSQL. To my mind, quite effective way how you can think about injection on a higher level. In case you want to kind of comment something, or for example, you just want to mention kind of comments like, this configurable repository is used only for dev environment, you don't know what could be. So you can use this approach with documentation, with notating, and mark this member as a non-bindable. So it won't participate in the binding process. So let's say like a description, and here add this annotation, which is non-binding. Yeah, and let's be default something, because we don't want to always mention it. Oh God. And we can back again to the MySQL and say like, okay, description, something I want to type here. I don't know, here remove prod. Run it, and this member won't participate in the binding. And you can say, okay, Dmytro, so that's all, like, that's what we can do with the injections with multiple candidates. Not. The thing is, still prioritization, nobody eliminated for some reason. It's when you have two potential candidates, but one of them is primary. And honestly, it's actually a sign of bad design, because prioritization quite often breaks all this entire process of testing, or it could spoil somehow runtime, and so it's not really good, but still we have it here. So we can kind of do this payment repository, we can remove it, we can go to the MySQL. So this is going to be as singleton, this is going to be as primary, and let's say here in the Postgres as well as singleton. Yeah, so let's run it, and back again, we're going to see MySQL as a primary candidate. But there is one interesting annotation that very shocked me. The thing is, you know, when you come to a new company, you don't know how to set up the project, everything is fails, 2 weeks passed, team lead asks, what are you doing? And say, I'm still installing, and I think, gosh, I would do everything just to run this project. I don't know what to do, everything is fails, no candidates, some problems with context and so on. You just think, I need to do something, and you are just quickly trying to resolve this problem. But Micronaut decided to come with a different approach. So let me show you this. This is PostgreSQL, okay, singleton. Let's go to the MySQL. Let's remove this primary, we don't need it. Let's run once again, we have a problem. Okay, it's failing because we have candidate, and right now it's going to be a magic. I don't know how they did it, and who can use it on the production, but if you want to, I don't know, troll your team lead or someone, you can do this. You can go and say any. You can inject anything randomly. Micronaut just picks up it randomly, and every time when you start, it could be MySQL, could be Postgres, so kind of anything you want. Very interesting annotation. I hope they won't deprecate it, and it will keep for the next releases. Okay, so this is about binding. And yeah, there is another binding by the generic type arguments, but honestly, I don't see any reasons to show it, because it's really rare case to my mind that we can use on the production or somewhere. It's not really applicable. Yeah, so primary, secondary beans, we mentioned that, and any. The thing is, Micronaut gives one interesting approach how you can forbid and limit injecting concrete types. Let's, for example, still you have library or high-level API or service, and you don't want that somebody gonna to inject this concrete type to the component or service, right? It can be changed, it can be modified, it can be kind of very flexible during the iteration and so on. So what you can do this way, you can go, let's go to the MySQL repository and say that, okay, this is singleton, it's fine, and I want to say that this implementation, concrete implementation, is going to be typed. What means by typed? It's like hidden by this repository, by this interface. And if I back to the payment service and I want to inject specifically MySQL payment repository, Micronaut will tell, no, you cannot. You just cannot. It's forbidden. It's actually limited. So what you need to do, you need to press Ctrl-Z and put, okay, this is MySQL, and MySQL will be injected. So this is how you can make sure that nobody is injecting concrete types, and it's really flexible, especially when you have annotation and you know that nobody is going to inject these concrete types, and you can really cool and frequently updates, do some kind of, I don't know, release new versions and so on and so forth, and you're going to have only one this interface, which is common. So again, really cool thing for less invasive approach. Okay, scopes. I need to shock you. The thing is, default scope in Micronaut is prototype. It's not the singleton. Why? Because you have two annotations. And okay, if we talk about in context, in terms of Spring, we use this annotation bin. But the thing is, bin is prototyped. So you have two ways how to declare a prototype in your application: is bin and prototype annotation. Out of the box, Micronaut supplies a lot of scopes. It's singleton, prototype, infrastructure, thread local. My favorite is actually thread local, because I was on a project where we used global state. It was in the thread local, and it was actually really a nightmare, but it is what it is. Like, we had a context here, and in this context was wrapped by thread local. Then we somehow processed this context and then closed this context. So it was not really convenient. Instead, you can use this annotation thread local, and you know that per each thread, you can get only actual data. And other things like refreshable, request scope. Refreshable, I suppose it's only used for the Lambda functions. Micronaut is really oriented on the Lambda, and they have very cool solution for that, how you can do Lambda and how you can use Micronaut with some complex logic. And if you need something, you can click event, and refreshable will refresh your context. So this bin is going to be refreshed when you emit this event, and so on and so forth. About infrastructure, I just going to talk about it a bit later, but it's something that you cannot modify, and I will tell you a bit later why. Yeah, so bin is the full scope. Here as well, there is such interesting approach, and as I mentioned before, Micronaut is awesome at annotation processing, and you can actually build entire kind of behavior based on the annotation. Like here, you have class foo, and this class foo is annotated by the annotation driver, okay? And this driver, we can see that by default, everyone who is going to be utilize this annotation driver going to be a singleton. But the thing is, someone wants to override this scope by adding prototype, but you cannot. You just cannot do that, because this overridden doesn't allow like that. But still, you can use different concept, which is, oh yeah, so that's why singleton is going to be a primary. So it's happy sun, but prototype no. So that's why it's set cloud. In case of you want to give your users opportunity to, gosh, don't install. If you don't want to allow that, you can say that, okay, default scope is singleton, but feel free, override it, I don't really care. But it works for all the scopes apart from infrastructure. Infrastructure scope is always fixed. You cannot able to override it anyhow, because it's kind of considered as vital for your application work. And it's something that you just cannot change or solve. So it just doesn't work. Another situation, you have a library, I don't know, maybe some Apache or maybe some other libraries, and you're not able to add your bin to the context, right? So you're not able to do that and put the annotation because it's already compiled, it's a part of your library. So what we can do, for this purpose, we use bin factories. Bin factories is a Spring configuration classes. So if you want to kind of add something to the context, you use these bin factories. By the way, let's take a look at that, how it works. So this is our typical bin factory. Let's uncomment it. And one interesting aspect about the factory is that singletons. So we are not able to kind of produce more than one instance here. And we can actually do like that. We can just say that we want to create MySQL repository, and we actually need to remove this one because it's not allowed to add in 2 times to the context. So we want to use factories, and let's take a look. Let's run it, and it's passed. So factory was used as a plain configuration. But one interesting aspect about the factories is that you're able to create bin of primitives and arrays. It's a very interesting approach. I never seen it in the Spring, but still. Let's say you have some kind of, you want to create a bin of your primitive. So what you need to do, let's, for example, you have connection pool size or something similar that could be scalar, and you're going to inject it to your other component, to your dependency. So in this case, you can create a primitive, call it as bin, and give it a name. By default, it doesn't take the name of the variable itself. You need to specify what the name of it, and you can inject it. There are plenty of limitations. I guess you understand. We're not able to track the life cycle of such bins because we don't have post-processing, pre-processing, we do not have kind of AOP and so on. So it just doesn't work. It's just like, okay, we can add it to kind of separate container with primitives. And it's going to work like that. So let's do like that. We can add it. We can create a constructor. Create a field. And then just let's try to, I don't know, I don't have logger here. So we're going to do system out for debugging purposes. Okay, let's run it, and we should see this, number 7 in our log. So yeah, we have here 7. So this is how we can inject as well primitives. Quite interesting approach. But actually, bin factories takes more important than just creating dependencies or primitives or whatever you want. Bin factories are very used when you want to, for example, utilize AOP, or for example, you want to customize the lifecycle, or you want to, for example, track the objects. So it's really a vital thing that could be resolved basically with factories. It's not kind of always, and I saw that documentation tells that you have to kind of choose one approach, but honestly life is more complicated, so you can mix it, it's not going to be a problem. So yeah, feel free to use factories if you want. Yeah, so we have here an example, and so on. Yeah, conditional bins. I very was impressed how they did it. They provide kind of tons of conditions that can decide whether you need this bin or no. There is, I don't know, maybe 100 or so ways how you can understand whether you need to instantiate this bin or no. Back again, good example with libraries. You have a library, and you want this library, I don't know, it's like enormous context with different bins. You don't need to kind of initialize everything or invoke something, or I don't know, somebody wants to kind of invoke instantiation of these bins in your library, and you just need to forbid instantiating them like at all. So there are a lot of ways. First of all, here I want to mention that, again, you can create conditions just with a small annotation with a lot of rules. These rules work as one unified condition for them. And there are like, I don't know, like here missing bin, or for example, you have this bin, or this is env, or this is every env apart from test, or for example, you have Java SDK, some particular version, or you have in a class path some class, like a lot of things, and it's list long, you can just learn and like, I never thought that there is so need in this conditional annotation and conditional requirements, but it is what it is, they provide like a lot of them. And yeah, so here rules, just what I mentioned. You can kind of create a lot of rules and declare it as one annotation. And this annotation you can use for your particular, for example, repository types, and it will be working fine and at the runtime, at the compilation time. So awesome. Another thing that Micronaut allows you bin replacement. In Spring, you are not to do that. I guess everyone remembers that if you want to replace bin, you do what? Aliases, like alias here, alias there. And if it comes to the test, you need to create alias, for example, your integration test and or mock or so. I had a lot of problems when we had some mix with context. And I remember that these replaces would resolve this problem. So you just, from the Spring, you cannot just get it directly from the container and replace it. So Micronaut allows it, and it works awesome. The thing is, bin life cycles here are the same. There are no kind of, I would say, some limitations like how my application should work, or it's like the same. You have second phase constructor or post constructor, and the same as for the pre-destroy. So Jakarta, they fully implemented, and there is no problems to declare here your own rules, how it should be initialized, and so on and so forth. So like, yeah, like here, for example, I can go to the configuration, where it was, just a second, in the factory. And here I can type like bin, like pre-destroy, and call some method that's going to be invoked as a part of the pre-destroy. It's my pain point. I never understood it, and I have to confess that I never use bin post processors. Most people use in Spring bin post processors for the reflection or for the post processing and so on. But what is really shitty about the bin post processors, you consume object, you do instance of, and you return object. And by object, I don't mean object, I mean type object. And bin post processor kind of works as global. You need to catch your particular bin, validate it, then you can call the reflection, get class, get fields, do injections, so on and so forth. For what reason, I don't know. So to my mind, bin post processors is a really sign of, as well, like bad design, and I never understood it, never used it, and basically even I saw one conference where one guy was presenting Spring, and he was asking the author of the Spring, and they were discussing these bin post processors, and the author of Spring was really unhappy with the solution as well. So they kind of concluded that it's not really a great approach. Instead, Micronaut doesn't provide anything of that, and Micronaut is fully it relies on the events. Let's, for example, you have some bin, you created this bin, and you want to be sure that you want to catch exactly this bin, do some processing, I don't know, do some operations, validations, and return the same bin. You don't need to kind of return something else. If I'm not mistaken, in Spring, when you were adding Hibernate mapping or so, it's internally had somewhere a bin post processor that returned you not the configuration, it was returning your real Hibernate object, session or something else. You cannot do it like here. So, yeah. And with these listeners, there are tons of listeners, like be initialized, context up, context down, kind of some context refreshed, and it's a lot. So you can use them instead of the bin post processors. So much better than having kind of some strange things, especially when you have reflection and you need to iterate through every single build. By the way, the last thing, maybe some of you only takes into account arguments with the performance, but instance of is really slow. So every time when you have a lot of beans, you need to check for the instance of and do the validation. As I mentioned, Micronaut doesn't have reflection, right? So Micronaut is reflection-free and uses reflection as the last resort. It means that if you, for example, I don't know, wants to use reflection, Micronaut says, okay, you don't need reflection, you need introspection. Introspection is more about self-observability, but from the Micronaut perspective, it's actually more or less the same. It doesn't really matter. And for example, if you want to get some fields, parameters, or for example, you need do something with your object, and by the way, reflection is like another way how you inject your object, you as well can do it with introspection. So how it works, and back again, it works completely at the compilation time. Let's take a look. We have here context is loaded listener, and we're gonna to operate with our payment service when the bean is ready and do injection. What we're gonna to inject? I have here a cheat sheet because time is up. So here we have UUID, and we would like to add this as a part of constructor, okay? And we're going to say, this is UID generator. So what we need to do, we just want some field in the class, inject some UID. Quite typical scenario, nothing special, want to inject something through the constructor. Plus, for the simplicity, I decided to use UID, and it's more convenient. And the thing is, yeah, let's do it like an optional. However, no, it's not. And we need to do this one. We need to provide annotation introspected. The problem, if you want to avoid reflection, you have to put this annotation everywhere. For example, you have a request response, and to be convertible from object to JSON, you need to mark it as introspected as well. Yeah, some drawback, but still, it's quite fast. And yeah, getters and setters. Let's do like that, because introspection is doing all injection with setters, through the setters or fields. You cannot like mix it up, or I don't know, like set accessible true or so. No, it just doesn't work like that. So instead, getter setters. Okay, we have it. And let's go back. Let's go back to the to our listener. So to read and make and enable observability of the project. Of the bean, we marked it as a payment service with introspected and call the get introspection. So we're going to have here entire information about our bean. And then we want to iterate through the arguments of this bean constructor. So, and in case we find this annotation with UUID, if it exists, we're going to inject here a random value, random UID. So we get this property from the arguments. Yeah, we get the type of it, it's string, just to kind of avoid class cast exception and so on. And then for this field, we're going to inject our UID for the same object. And that's all, like very straightforward. And if you take a look at the introspection, you can have like a lot of like bean methods, properties, constructor arguments, annotations, names, stereotype, so on. It's like a real self-observability, just like it was mentioned. And one thing, minor thing I want to mention, that introspection is not new. You can find it in Java 2E for the enterprise. You can find as well introspection, but for that particular case, it's more specific for Java enterprise. So yeah, let's test it out, okay? And we'll see whether it should work or no. Let's do like assertions, assert not now, and payment service, get UID. Let's take a look how it would work. Oh, it failed. Okay. because payment injectable for UID class example. Okay, let me do like that. Let me do like this payment, and let me do here optional. Okay, yeah, I know why. I know why optional, because by default Micronaut tries to do inject dependency from the context, and then it invokes the context, so it's fine. So, or else let me null. Easy one. Let's take a look. Yeah, it's success. For someone who is skeptic, let's do this. I live system out, get UID, and let's run. And we're going to see here UID. Yeah. So one thing actually I would like to mention here about the containers, if we talk about the scopes, I'd like to actually wrap up the scopes, that you don't need actually to use lookup. So let's go back to the payment service again, and we can say that, okay, I just want to have just a second, this MySQL repository, I want to do it as a prototype, okay? Prototype. And every time when I call it, I want to have like a new instance of it. How it works with Spring, who remembers? Come on, interview, who passed the interview? It's lookup methods, right? You kind of create dummy method, you mark it as lookup, and it's quite dummy because it throws unsupported or something else. So in Micronaut, you don't have it. You shouldn't actually do that. Instead, you can do this trick, which I really like. You have bean provider. So here you have bean provider. And yeah, you need to change here the argument, change to the bean provider. Factor. Okay. And every time when you call something, when you call the safe, you need to put here get. Bean provider reflects the scope of your bean. So whether it's singleton, prototype, thread local, so on, you operate directly with the bean provider. So it's like another thing why it's very important to have, why it's important to understand the containers that Micronaut provides and supplies, and why it's really easy, because you don't need to provide anything, especially some kind of lookups, which I really don't understand. And then let's here, let me make kind of saving 2 times. And if you take a look at the saving, particularly, I here call hashcode a couple of times. Back again, just for the validation. Okay, let's do that. And okay, possible candidates, MySQL, yeah, of course. Let me do like here, payment servers, MySQL. Just a second. Prototype. Maybe something different. Oh yeah, of course. Yeah, sorry for that. We don't need prototype here. We already have it in the. We already have it in the factory. Yeah, that's what I mentioned. It could be like a potential issue when you mix it up. And yeah, so we have here UID. No, we have here hashcode, some digit, and here hashcode. So yeah, that's how you can actually do this. Reflection of life cycles. So yeah, I just want to mention that introspection is a big topic, and maybe you heard about this guy, Graham Rocher, if not mistaken. He constantly speaks about the introspection, how it works, why it's cool, and so on and so forth. But alas, he didn't mention how they realize it, and in documentation doesn't tell anything how they did the implementation of introspection. But yeah, that's like a very cool thing. That's all actually. If you want to connect, feel free. And yeah, feel free to rate the talk. Yeah, so that's all.